Welcome back to a lecture series on GIS, and this lecture it is about topology and relations, relational query, and we have seen what is topology and what is the use of topology. Once if the topology is linked with the power, the capability or the analytical capability of GIS will increase. The error during digitization or error after completion of all the process will be reduced only if you construct a topology in GIS. GIS is very effective tool when topology is applied. Otherwise, if you simply digitize and then you will not know that whether the link is established between the line or a polygon or polygon to line. So these problems will come. Of course, this I have experienced when I am digitizing. After that, if you run a topology, you will find the topological error. Once if the topology is attained, and then the query becomes so easy, relational query, you can ask many number of questions. But topology, once if you construct topology, how the errors will come and then how relations are going to be established in GIS is the concept of the present discussion. Under this discussion, we are now going to discuss about the link between topology and relations, combining the functions of relational database and topology. We have also seen in the RDBMS that what is relational database. A database is connected with each other. It's like normally we used to give examples like grandfather to father, father to child, child to grandchild, and it is like that. There should be a link between your parent. It's a link-like features, relations, which is a feature which is connected either on top or on the bottom. So this topology will establish a rule called relational database and topology. We can see a powerful capability of GIS, and of course the illustrations are going to give. There are four. I am going to use four figures by using a polygon A through C to explain about how the relational databases and topology establishes. Let us say we need to know if there are any sets that have a polygon A with large B. Of course, that I will tell you that we are going to use a word called large and small. It is a relative terminology to understand very simply. But normally we used to explain with how much of area it covers in GIS. Normally, once if you digitize a polygon, you will get area. But here, whatever the explanation it is going to give, maybe what we are going to use, A is a large, or B is a large, or C is a large, or vice versa. A is small, B is small, or C is small. Topology will provide connections between the polygons or lines, and the relational database will sort through the size of the attributes. Of course, you will enjoy the subsequent lectures of understanding how topology is going to play a key role in GIS. There are four sets now I am going to explain. Of course, now if I read this, you will not be able to understand. You will let to know that this is set 1. This is set 1, no attached B and no connections. So there are two polygons digitized. It is all separated. A is bigger than B. B is a very small size, but you know that there is no connection. You cannot establish. Suppose if you want to ask a question, it cannot be able to link together. That here there is a problem as a gap over here. Maybe so here topology rule could not be able to play well to establish. Here large B, you see large B is attached to C, but C is very small. There are two polygons A and B and C. B is that small B is detached, that is called C. Here the connectivity in terms of topology is comparatively not established well, but topology is linked over here. And similarly, this is a set 3, small b attached through C is large. So here the connections are there, but not 100% well connected. And set 4 is 1. Set 4, you see there are two big polygons is fully covered and connected. Large B and large C attached completely. Here it is completely attached. Of course, this is an external area. But whereas you know that here and you see B is attached with C, but A is detached. Comparatively among four, set 4 is good. So this is the topology and relational rule for a set A and C or detached C is very small. In set 2, A and B, A is large, B is little small, but B is not 100% connected with C. C is small. And similarly, A is bigger than C. Sorry, C is bigger than A and it is attached with B, not fully established. But comparatively among these 4 combinations, set 4 shows a polygon that have a large B and large C polygons attached. Query, suppose if you ask show a polygons that have large B polygon and large C polygons attached, what will happen? Immediately this will come. So multiple connectivity, that is the speciality of the topology. Topology connections can work on a set of lines called network. Network have nodes. We know that when if you digitize, nodes is the starting point. In between you have vertex. Networks have nodes at each intersection. Wherever the intersection comes with respect to every chains or a line, it is relatively easy for topology to find a path from, say, site A to site B. It uses the line, that is chain, to which or A is attached to search the nodes to find other lines that may eventually lead to site B. And of course this is very excellent multiple connectivity. If you do the topology, you will get a good connectivity over here, and see site A is connected to site B via multiple nodes and lines. Site A is on line 10. Line 10 has node X. Node X is on line 3. Line 3, of course, this is the explanation you will know in the next figure, next slide. Node Z is on line 12. Line 12 has site B. And this is that example. You see, you have a line, one line, and this is the second line, and this is the third line, and this is a 9th line, and this is the 11th line, and this is the 12th line. 4, 5, 6 by mistaken we have not given. This is 4, this is 5, this is 6, and this is 7 also, and 8. This is 9, 10 is here, 11 is here, 12 is here. So if you take a line 10, in line 10 you have a node X. That is the first point in the last slide. The node X is there in line 3, so that is the second connection between the line and the nodes. The line 3, in the line 3 you see, line 3 goes, and then in the line 3 you have node Z. Node X is also there, node Y is also there, node Z. In node Z, you see node Z is on a line 12. You see the connections, how GIS is establishing a very excellent connections, so that if you have such type of very excellent connections, whatever the query you put in GIS, GIS will ready to answer. And you see that the same site B is on line 12. Site B is on line 12. Site A we have seen in first one, site B is on, this is the network. You see this is what we have seen in the last slide. Site A is on line 10, line 10 has node X, node X is on line 3, line 3 has node Z is on line 12, line 12 has so you see this is the one, 10, a line 10, node X is there, a node X is on line 3, that is another point. After that, if I click line 3 is on node Z on line 12, line 12 on side B. So this is the relations one by one. Very clearly it is explaining about the linkage between the node and line, so that it will be you can very well establish whatever the questions you ask, it will immediately read from the attributes of either a line or a polygon or a point through which it will establish. And topology, what is the advantages of topology? It is an intelligent vector. It is automatic recognition of spatial relationship. Multiple linkages will be there. Magic programming. So intelligent vector, as we know that there is a functionality attached to topology data structure. I mean at the back end. Nodes and chains know much about their surroundings. Yes, in the last slide we have seen, and this knowledge can be used for a variety of powerful analytical tricks. Automatic recognition of spatial relationship is established. to understand the connectivity, adjacency and containment. So this is the topology. Connectivity, to establish the link between connectivity, adjacency and containment are included in topology. There are other spatial relationships that can be constructed, and it has a multiple linkage, it has a magic programming. Multiple linkage, each feature is linked to other features providing multiple connections to join them. Magic programming, because topology possesses the previously mentioned powerful characteristics, connectivity, contingency and adjacency. The programming seems almost magical to many users. So with this, the discussion of topological and relationship query is of more effective when you do this relationship query with topology in GIS. It will be of more effective. So with this, the lecture has come to an end. Thank you.